Greetings and welcome to week 3 unit 5 on peer teaching, peer review, critical incident analysis and small group analysis. In the previous unit we understood the features of instructional components, e-portfolios, learning journals and reflection journals. Now we will look at some more instructional components including peer teaching, peer review, critical incident analysis and small group analysis. Peer teaching and peer review have been practiced a little bit in some of the institutes, and it is an effective method, and they are instructional strategies grounded in active learning and collaborative engagement, because the students are actively getting engaged into something, and that is why peer teaching can make a considerable difference. But these are possible only if your curriculum is not overloaded and you do get some time either in the lab or in the classroom where peer teaching can take place, though in some cases it can be organized a little bit outside the classroom also. These are used to deepen understanding, improve communication skills and foster critical evaluation. Let us look at each one of them separately. Peer teaching is an instructional strategy where students teach other students, often within the same course or program. It can be structured formally or informally. Formally means the instructor organizes that, assigns so and so will teach this topic either to a small group or the remaining class, or informally study groups can be formed and outside the classroom they work together, but still with some type of instructor involvement. At least initially, study groups without instructor involvement will not satisfactorily function. Study groups, for example, the formation of study groups is a very common thing that is used in many American universities. Here it may happen informally, but not that very well structured manner. Key features of peer teaching include role reversal. Obviously, students take the role of instructor, reinforcing their own understanding. Because if you want to teach, though you may feel, a student may feel that he has understood something, but once you are required to teach the same thing to others, it will take considerable preparation and better understanding of that, and also how to present it to others. All these issues will come. To that extent, that particular student's understanding deepens. And scaffolding, students build knowledge together, progressing from simple to complex concepts. So you can include scaffolding into your instruction. How do you plan your scaffolding is again the student can get involved and he can present his version of it to remaining members of the group or members of the classroom, or to just one more. Maybe two students can form a kind of a peer teaching and peer review kind of situation where one student teaches, the other student reviews, and you on another topic the other student teaches and the first student will review. That kind of thing also is possible to do. It is a part of what you call zone of proximal development. This is a concept due to Vygotsky's theory. Peer instructors support each other just beyond their current capability. That is, if you whatever you know, if you a little bit of increment over that, if you are attempting, it is easier to understand rather than take a big jump. Whereas from one concept to another, if it constitutes a big jump, there is a possibility of not satisfactorily understanding. That is proximal development that can take place readily in peer teaching. Mutual benefit, both tutor and learner gain deeper insight. Why we bring the tutor here is tutor can plan or oversee how the peer teaching is taking place. In that process, tutor also gains a deeper insight as well as the student. Improved communication. Obviously, when students are communicating something to another group of students, his communication skills will have to improve and will improve. And some examples in engineering, what can be done. Maybe these examples will tell you where peer teaching can be actually used. Study groups where each student explains a different topic, either in mechanics, materials or thermodynamics, anything that you take. In a study group, each member takes one topic and explains to others. Okay, how do you sequence the topics? The group can decide. The study group can form based on the particular subject you are all studying together. So, and the study group same study group may go across different subjects or different semesters, or you may keep changing the study group also. For different subjects you can have a different combination of students for a wider experience. For example, teaching key concepts of control systems to peers using diagrams and simulations. Somehow the control systems course always seems to be somewhat difficult, and students they do not like the course, nor they perform very well in that course. So, this is one course like electromagnetic theory that peer teaching can help everyone. Explaining the logic behind programming algorithm during lab reviews. Digital logic simulation walkthrough. A peer demonstrates step-by-step simulation of a digital logic circuit using software like LogSim or Multisim. Thermodynamics concept clinics. Students lead review sessions explaining entropy, Carnot cycle with problem solving examples. CAD software demonstrations. Skilled students provide live tutorials on SolidWorks or AutoCAD modeling and best practices. So, these are some examples where you can create any number of examples in engineering where peer teaching is beneficial to all the concerned. And how do you assess peer teaching? If you ask somebody to come and teach and leave it at that, it will not serve purpose. One is assessment is pre and post testing, which is nice to say that, but may be difficult to actually implement. You conduct a quiz before peer teaching and conduct another quiz post teaching, and if there is improvement, the peer teaching is effective. Observation checklist. The instructor observes and rates peer teaching sessions using criteria like accuracy of content, engagement strategies, communication clarity, and responsiveness to questions. Peer feedback forms. Learners complete short feedback forms on the peer teacher's performance. That is, if peer teaching is one part of instruction, and if you want to evaluate how he has performed and you want to give some weightage to that, then you can follow this assessment. If you do not want to assess or give any weightage to that, it can be taken advantage in a slightly different way, okay, if there are no marks to that. Self-assessment by peer teachers. Peer teachers can themselves can fill up, can self-assess, reflect on their teaching experience. Instructor evaluation of artifacts. Now instructor comes into picture. It will review teaching plans, teaching aids, or session recordings and so on, evaluate based on content correctness, structure and creativity. Rubrics based assessment. Design a rubric with criteria, that would be the best. The instructor can design a rubric where exactly he wants to focus or what advantage he wants to take out of peer teaching, and that rubric can be used to assess the actual peer teaching. Learning analytics. If you are using any digital platform, track video engagement, quiz attempts or discussion forum participation if peer teaching is done online. That is the next level, online. Personally, I would consider, if you want to assess and give some weightage to peer teaching, use a rubrics based assessment. Rubrics will also communicate to the student what exactly you should be doing. How to do a good peer teaching will depend on what are the criteria that are being applied to evaluate his peer teaching. That itself will give him how to go about preparing that. Now the next thing is, this is also a good learning experience, namely peer review. So peer review is a formative assessment activity where students evaluate and provide feedback on each other's work based on clear criteria. Somebody presents, let us say he presents a design of something, and the next person will actually review it following a set of criteria and gives that feedback to the presenter. And that is that constitutes good learning both for the reviewer and the student who presented his work. It helps learners reflect, critique and improve their work before final submission. This can be an excellent informal method if you want, because it is mainly meant for formative assessment. Two students can form a group and they can review each other's work before the final submission. Okay. Key features: constructive feedback, focused on strengths, weaknesses and suggestions for improvement. Rubric based evaluation, that I would always consider is the best method. Critical thinking promotes analytical skills as students assess peer work. Multiple perspective encourages exposure to different problem solving styles or technical approaches. See, all these features can be incorporated into one single rubric. If the rubrics are satisfactorily designed, then that is the best method. Same rubric can be used by both the students for reviewing each other's work. Some examples of peer review: reviewing peers' CAD models for functionality and design logic, evaluating lab reports for clarity, data interpretation and conclusion quality, giving feedback on programming assignments in software engineering, assessing design projects in a final year project or any project based courses using rubrics. Peers assess the use of tools like LT-Spice or MATLAB, Simulink, verifying waveform correctness and parameter settings. Groups exchange and critique thermal cycle calculations or HVAC system designs. Students evaluate each other's source code for readability, documentation, logical structure and adherence to programming standards. So, this will be the best one really to practice peer reviews. Teams provide structured feedback on clarity, completeness and maintainability of system documentation in a project. Now, these are some assessment criteria for peer review. They are self-explanatory: quality of feedback given, use of rubric or criteria, depth of engagement, tone and professionalism, timeliness, a reflection on received feedback, a revision quality. So, you can use this if you want to assess peer review and give weightage, but you can also use these criteria and design a rubric based on that and practice peer review for formative assessment. Okay. Common tools for assessment of peer review if you want to give weightage: rubrics used or self-assessment forms or instructor moderation or revision logs and peer review scores. So, you can use any of these tools to, or some of them or all of them, to kind of assess the peer review of done by a person. Now, as we said, for peer review it can be used for, if it is used for formative assessment, you do not have to go through elaborate assessment, but focus on what has been learned and how to improve. For me, the ideal one is if there is a complex assignment each one of the students is doing separately, and before final submission 2 students can review each other's and see whether there is any improvement that can be done. Okay, that is part of the learning. Now, we come to next instructional component, namely critical incident analysis. Many times some critical incidents occur where it is emotionally disturbing to the student or to the learner, and he has to come out of that emotional disturbance to proceed with his work. And if we can identify, there may not be too many incidents like that, but if there are some critical incidents that can be identified, and analyzing that critical incident can be of great help to the learner. And a critical incident analysis is a structured reflection on a significant, often emotionally charged event or experience during learning activity or teaching situation. If there is one such incident has occurred, then you reflect on that in a structured way. So, it is beneficial to us instead of getting into either a depression or feeling very bad about that critical event. One can learn from that. The goal is to understand what happened, why it happened, what can be learned from that. That is the purpose of critical incident analysis. So, it promotes self-awareness and professional growth. This can happen in a professional part also, not necessarily during teaching and learning. Identify movements that impacted learning positively or negatively. Connect theory to practice in real life engineering contexts, or enhance decision making and ethical reasoning. So, any of these things can be achieved if you do if you analyze your critical incidents in a structured manner. Typical steps, here again Gibbs cycle often used for this, that is, you describe the incident, what happened, feelings, what were you thinking or feeling, you can record that, evaluate what was good or bad about the experience, if you can record, and then analyze why did it happen, what were the underlying factors, if you can analyze and record that, and then conclude what else could have been done. If these are the things that shouldn't have happened, what else can be done? And then action plan, what will you do next time? So, this can be done individually for oneself, or with the help of a mentor one can do a critical incident analysis. If you do it once with the help of a mentor, then subsequently you can do it to yourself and greatly improve on your own. Examples of CIA: a design project where the chosen solution failed due to missed specification. These things do happen in engineering. Something has been assumed and you design and it does not work. So, that is a critical event that occurred, and whether a group or an individual can analyze the critical incident. An ethical dilemma in a group project involving unequal participation, that is, this happens very frequently in undergraduate programs. If you form a group, there will be some freeloaders, and that is always a complaint. Okay? But instead of taking any punishments and things like that, if the group together can do a critical incident analysis, then possibly it will correct itself. Handling a safety breach in a lab environment, receiving conflicting feedback from mentors during a project. If two mentors are there for a project and then you receive a conflicting inputs from them, that becomes a critical event. For example, a peer designed PCB malfunction causing a short circuit during a lab. Now, the critical incident analysis will focus on errors in design assumptions, communication gaps in documentation. Generally, when two people are involved, one person does something and communicates to the other person. In that process, there can be lots of gaps, and that itself constitutes a great learning experience. Importance of simulation and peer review, broader implications of design safety and accountability. So, the CIA critical incident analysis can focus on all this. And if you want to assess, yes, there are plenty of elements: clarity of incident, critical reflection, technical insight, ethical and social awareness, a learning outcome, depth of personal engagement, and structure and coherence. These are all the elements that can be used in the form of a rubric, or they can informally be used to together you can use it to analyze a critical incident. Now we move to another instructional component, namely small group activity, SGA that we call it. Small group analysis is a formative feedback method where a neutral facilitator meets with small student groups to collect feedback on the course, learning activities or outcomes. It is a collaborative dialogic method rather than just a survey. If a faculty member is agreeable to another colleague to come and do the small group activity, it will be a great thing to learn from that. It is a structured activity to that extent, instead of merely somebody coming and sitting in a class and making some observation. A little more structured thing is to use small group activity. It typically focuses on group dynamics, instruction clarity and student engagement. Purpose: understand group perceptions of what is helping or hindering learning. Improve course design, instruction or outcomes based on actual group needs. If the students, let us say in a course, do not like the outcomes themselves, or the outcomes are too far-fetched or any of that, if they feel uncomfortable and if they can express, it can constitute a feedback to the teacher to see whether the outcomes can be modified or some instruction method can be changed. Encourage student voice and engagement in course improvement. So, that is one part of the student participation. Identify common patterns across student experiences. That will also help. Typical procedure in this: it can be used as a part of mid-course review or post-course outcome. That is, trained facilitator meets 5 to 10 students. For example, in a group of faculty in a department, 2 or 3 people can be identified as and trained specifically for conducting a small group activity. 5 to 10 students he will call together as a group and conducts the activity. Students discuss what is going well, what is not working, suggestions for improvement. It should be structured, it should not be kind of free for all kind of thing. The facilitator synthesizes the data and shares a summary with the actual instructor. Instructor may discuss and respond to feedback with the full class. Okay. So, that is some activity for the facilitator. Where can we use SGA in engineering education? Midterm feedback during lab intensive or flipped courses, evaluating group dynamics in a project based courses, improving instruction in difficult courses. People always give this example: control systems and electromagnetic theory. Evaluating learning outcome achievement and suggesting changes to curriculum delivery. So, you can use SGA for this. These are tools and these are components that can be used if the teacher wishes. Okay. That depends on the teacher making the decision. And if you still want to assess the SGA itself, then you have these factors: quality of student feedback, instructor responsiveness, improved group functioning, enhanced instruction, and learning gains. So, if you want to really find out the value of this, and if somebody wants to really assess the whole thing, then you can use these criteria for assessing. Now, let us look at summary of instructional components. In this whole week, we looked at a large number of instructional components. We presented some selected instructional components, not all of them: analogies, metaphors, graphic organizers, concept maps, mind maps, e-portfolios, reflective journals, learning journals, peer teaching, peer review, critical incident analysis, and small group activity. We presented some. There are many more instructional components used by teachers, and new ones are still getting generated. So, it is not as if this makes a complete list. This list of instructional components are selected by me as something that is based on my judgment. For example, you can explore other instructional components if you think they are better suited to your course and in your context. By all means, use them. Some instructional components like analogies, metaphors, and graphic organizers can readily be used by individual faculty members on their own initiative or intuition. You feel that it is good to use that, please go ahead and use. You do not require very elaborate infrastructure for that. Use of concept maps and mind maps for instruction and assessment requires availability of some software tools. Faculty with some training can use these ICs in their courses. A training on concept maps is not difficult. The tool is very simple to use, both mind maps and concept maps, and all that you have to do is create one concept map for your own one of your subjects, and you should be able to help the students create also concept maps. Okay? But the tool should be available. If you want to use it as a part of in a classroom, then you need a particular classroom with all the facilities, or otherwise you can go to a lab and make the students work on the computers, PCs, to generate concept map, let us say, for a part of the course. Okay? And use of all other instructional components, whatever we are talking about, anywhere from reflective journals to e-portfolios to small group activity and all that, they will require policy decisions and complete support from the management. Without that, you cannot implement. One faculty member cannot implement that. They require the participation by all faculty as well. Addressing deep learning and affective factors and all program outcomes, if that is the goal, then it is possible only if at least a subset of these instructional components are integrated into instruction. You cannot address all POs or addressing affective factors and so on if you are not willing to use any of these instructional components. Okay? If you want to achieve that, the students have to engage. Let me make sure. If you want him to train and analyze, create, he has to participate in that effectively, and that kind of thing can only be done by using at least some of these instructional components. Not all of them, but at least some of them. If you use, then only you can achieve all the POs effectively. And in the next week, we will address project based instruction, problem based instruction and scaffolding in instruction. And thank you for your attention.